Hello everyone, my name is Vineet Shrivastava, a research scholar at Manav Krishna International Institute of Research and Studies, Faridabad. Today, I will be presenting our research on novel movie recommender system that integrates hesitant fuzzy clustering with a convolutional spiking neural network. Right now, I am sharing my presentation with you. So the title of my paper is Hesitant Fuzzy Clustering with Convolutional Spiking Neural Network for Movie Recommendation. The outline of the paper is like this. First, I am talking about abstract, then introduction, after that literature survey, the proposed methodology, results and performance evaluation, conclusion, references, and in the end, a little bit of biographies of authors. So, starting with the abstract, recommender systems plays a crucial role in assisting users with selecting movies tailored to their preferences. Despite significant advancement in this domain, existing approaches overlook the importance of user-specific recommendations. This paper introduces a novel movie recommendation system that integrates hesitant fuzzy linguistic bi-objective clustering with a convolutional spiking neural network to enhance recommendation accuracy and personalization. In our approach, begins with data acquisition from benchmark datasets, including MovieLens 100K and MovieLens 1 million. After that, content-based features are extracted using ternary pattern and discrete wavelet transforms. These extracted features are then utilized in hesitant fuzzy linguistic bi-objective clustering algorithm to select optimal clusters. Subsequently, a convolutional spiking neural network predicts user movie preferences based on these clusters. The proposed system is evaluated against existing methods, specifically the multi-modal trust-dependent recommender and graph-dependent hybrid recommendation schemes. The results of our approach shows a significant improvement of 13.79% and 16.47% from previous approaches. This study underscores the potential of integrating hesitant fuzzy clustering with advanced neural networks to refine and personalize movie recommendation, marking a substantial improvements over current methodologies. Moving forward, now there is an introduction for hybrid recommender systems. And the hybrid recommendation systems combines multiple techniques to enhance accuracy and overcome limitations. Hybrid recommendation systems objective is to optimize performance by leveraging the strength of different recommendation approaches. The key components are integration of collaborative filtering and contents-based filtering, incorporation of knowledge-based and hybrid models. After that, the advantages from this can be improved accuracy, enhanced robustness, and a very famous problem, cold start problem for recommendation systems. That can be mostly reduced with the help of hybridization. The various type of hybrid models are weighted hybrid that combines assigned weights, feature combination, merges features of different models, switching hybrid, activate specific models based on user item characteristics. In hybridization, there are several challenges like complex integration and scalability issues. There are various broad areas for hybrid recommendation systems. These are the various mentioned broad areas: e-commerce, retail, streaming services, social media platforms, news and content aggregation, online learning platforms, travel and hospitality, healthcare and personalized medicine, financial services, job and career platforms, gaming industry, real estate, human resources and talent management, social networking, automotive industry. Now, starting in the paper, we go through a literature survey. In that particular literature survey, we have taken amount of scope is of 2014 to 2023, a decade, in which I have utilized ACM, IEEE, Springer, MDPI, Scopus related database studies mentioned in the references. And we can say that the review highlights the evaluation and current trends in hybrid recommender systems, offering insights to the strength and limitations of the existing approaches. This is our literature review. These are the highlights. For example, a paper given by Vahidi in 2014 about component-based hybrid model for genetic recommendation for hybrid heterogeneous networks. Performance metrics was recalled precision curves. Pros was paper of a rapid deployment of valid variety of recommenders in a heterogeneous environment, and limitations was computational cost of generating and optimizing many components for the hybrid model is very high. Another paper given by Zhang in 2015, a hybrid recommender system based on user-recommender interaction aiming to improve recommendation performance in real-world scenarios. Performance metrics were recalled diversity, improve recommendation performance, and provide a more personalized and practical approach to real-world scenarios. Limitations were the evaluation approach has limitations in calculating recall due to the lack of explicit calculation. Moving forward, Astrub in 2016 gives a novel approach to managing the complex matrix completion settings in recommender system using neural networks and autoencoders with a focus of incorporating side information to elevate the cold start problem. The performance matrix was RMSC, excellent performance in collaborative filtering, competition with the set of art algorithms, effective integrate side information for improved recommendations, limitations for review required additional computational resources. Another paper given by Jiangxi and Zhu in 2017, a collaborative filtering algorithm based on hybrid similarity to improve the quality of recommendation in the context of large data processing. The performance metrics was mean absolute error, and we can from the findings of the paper, the author gives that low mean absolute error values compared to the traditional collaborative filter algorithms. Limitations was that the complexity of determining the weight factors in the neighbor set size, which may require experimental tuning. Another paper given by Yuba Wang in 2018 that proposed a sentiment enhanced hybrid recommender system for movie recommendation on the Spark platform. The performance metrics were TP rate, FP rate, precision F1 score. The pros was improved accuracy and timeliness of basically mobile recommendation systems. And the limitations were lack of comparative analysis, robustness testing, and ethical consideration limited generalizability. After that, in 2019, Karen Cano present a comprehensive and approach of everything regarding to Abbott recommender systems, all the metrics that were used in that MAE, RMSC, precision, recall, F score. It offers valuable insight in the challenges, technique, and evaluation fields used in this field, and lack of detailed analysis are the limitations. After that, Kiran ETL in 2019 proposed a novel approach to recommender system using deep learning techniques. Now the deep learning is introduced. Performance metrics were MSC, RMSC, ME, R squared. It provides a novel approach of recommender system using deep learning techniques. It does not provide a clear semantic explanation different in predicting ratings. MuETL in 2023 gives a novel movie recommendations that combines deep learning technology with multi-modal data analysis. Performance metrics were single-valued matrices with non-zero singular values. Use of multimodal data such as movie posters can improve the performance of the movie recommendation system. Need of large amount of multimodal data was required. In a paper in 2022, Shrivastava et al. Fully connected neural network with matrix factorization and evaluated performance using MovieLens dataset. Now the dataset is MovieLens here, which improves accuracy for MAE and MSC, and it can extend complexity and potential challenges in implementation and maintenance. In a paper given by Darban ATL in 2022 about the graph hybrid based hybrid recommendation system with autoencoder feature of extraction to improve recommendation accuracy. Precision metrics for MSC, precision recall. This was the one of the paper that was a comparative paper for our approach. The pros was it introduces a novel GHRS approach that effectively addresses the cold start issue and improve recommendation accuracy by leveraging graph-based modeling and autoencoder feature extraction. The limitations of the paper were the need of further investigation into the optimal clustering method for the feature space and the lands on datasets with specific user and item side information. Another paper given by Shrivastava, comparative ETL in 2023 is about the comparative analysis of functionality and aspects of hybrid recommender system. That how can various accuracy metrics, performance metrics can give a comparison with other approaches. Moving forward, two more papers were there about the Muhammad Al-Fajnid, Muhammad Fadel Al-Junid ETL proposed a efficient deep learning approach for deep learning collaborative system and the performance metrics was RMSE. It also told me about the deep learning approach, or it is not recommended for a large scale recommendation system as it is for the small set of data set. Susmita ETL, another paper of comparison is trust aware recommender system that addresses challenges in multi movie recommendation systems and evaluates different recommendation models to find the best approach, the precision metrics, the performance metrics for accuracy, mean squared errors. So according from these research guides, we have found that multiple research articles highlights progress in overcome challenges like cold start, data sparsity, and enhancing recordability. In spite of this progress, there is some kind of noticeable gap in that absence of unified standardized hybrid recommender system, which we try to do in our proposed approach. Current model struggles to seamlessly integrate diverse techniques, limited consideration for user sentiments, trust, and social influence. A unified approach is required to address challenges, providing versatility for enhanced accuracy, personalization, and user satisfaction. Now, this is our research methodology. First of all, we acquire data from MovieLens 100K and MovieLens 1 million dataset. From that particular dataset, we have extracted ternary pattern and discrete wavelet transformation. This is what the content-based features were extracted. From those content-based features, extracted features, we make cluster with the help of hesitant fuzzy linguistic bi-objective clustering. And the main work is about predicting user preference is did by deep convolutional spiking neural network. In the end, we have evaluated the performance of our model. Now, the proposed methodology is dataset is MovieLens 100K dataset, 1 lakh rating with 943 users, 1682 movies, and MovieLens 1 million dataset, 10 lakh ratings from 6040 users, 3952 movies were there. These are journal standard datasets can be downloaded from GroupLens website. Now, the second phase of content-based feature extracted, we have extracted basically feature extraction. We employed ternary pattern and discrete wavelet transforms. The ternary pattern encodes ratings into 3 distinctive values, which are then processed using discrete wavelet transformation to decompose rating into frequency components, enriching that data set with additional features. This is how the ternary pattern is done. Content-based features are extracted. For example, rating large enough for original rating is 3 or 2, the ternary rating will be 0. Original rating 5 or 4, ternary rating will be 1. If original rating is 1 or less, ternary rating will be -1. Similarly, for the modified version of for 1 billion and for 100K datasets. Now, after that, we have utilized we have did the step of cluster selection using hesitant fuzzy linguistic by objective clustering. This is we apply this particular clustering based on user ratings and movie genres. The process helps in categorizing movies in clusters such as poor, average, good, facilitating more accurate recommendations. Now, the clusters after the cluster selection, we have utilized the deep convolutional spiking neural network for the recommendation of movies. First, we go it for 100K dataset, then we go it for 1 billion dataset. The convolution architecture is a convolution layer with 32 filters and dildo activation. Max pooling layer was given, flattened layer for feature extraction, dense layer for learning patterns. Hyperparameter training is done. Model compilation is based on binary cross entropy, loss function, Adam optimizer. Training is done on model with training data, validate the test data. So after utilizing the whole parameters, whole technique, proposed method, the following results were occur. As we see from the graph that with comparison of MTML-MRS, the multi-trust, model movie recommender system and graph-based hybrid recommender system, our proposed approach HFLBC-DCSNN-MRS, the hesitant fuzzy logic based clustering, bi-objective clustering with deep convolution spiking neural network movie recommender system have shows a significant improvement in terms of accuracy, precision, recall, and F measure. So, and also in calculation of calculating moving forward, the proposed method shows a improved reduction in terms of various epochs in mean square, in terms of mean square errors. It shows 7%, 4% respectively from MTML, MRS, GHRS, MRS, the multi-trust, multi-modal, multi-linguistic movie recommender system and graph-based movie recommender systems. 7%, 4% for 50 epochs, 6%, 10% for 100 epochs, 10%, 8% lesser mean square error for 150 above, 16, 12%, 6% lesser mean error for 200 compared to the existing methods with the board dataset. So this shows a significant improvement in error reduction. So these are the improvements that can also measure in a tabular manner and also mentioned in my research paper. It's about the accuracy is 30.79, 16.47, precision 23.58, 16.16, recall 10.11, 19.51, and F major 23.25 and 26.41 respectively. So in the end, we can conclude that the proposed hesitant fuzzy linguistic bi-objective clustering demonstrates effective results in combining cluster for feature selection with neural networks of classification and recommendation. The significant improvement in accuracy and personalization make this system a better choice for movie recommendation as comparison of previous approaches. So also the result shows that this system is better choice than previous approaches and is not restricted to the movie recommendation. This can, as it is a generalized framework, you can utilize on the system is based on users likes and dislikes and ratings. This can be utilized for the product recommendation, for the book recommendation, so many things that can where the recommendation can be utilized. So future works can be utilized for the exploration of scalability and applicability of our approach in different data sets and also the different domains, paving the path of development of more complex and effective recommendations. Finally, here are the references. There are the various references that have utilized, mentioned in the paper also. And this is the short biographies of myself and my supervisor, Dr. Suresh Kumar. My name is Vineet Shrivastava, research scholar in Computer Science of Engineering, Manav Rashna International Institute of Research and Studies, Faridabad. And Dr. Suresh Kumar, professor at Department of Computer Science and Engineering at Manav Rashna International Institute of Research and Studies, Faridabad. Thank you so much.